Alright, so today I'd just like to go over basically what I've done so far in the last couple months. For starters, is I finished printing the internals of the ROV housing. So this is the shell, it's got 100% PLA infill, and what I'm going to do is I've got a little insert that's going to house all the electronics that I still need to print, and that's going to go right on top and hold everything together nicely. These two pieces are demonstration pieces. These are not 100% infill. These are just to sort of get an idea of how the whole thing will fit together. The real model will be gray, as is shown on the website. So that's the status of the 3D printing. We're in a really good spot with the 3D printing. I'd also like to show and demonstrate the motor setup. So what we've got right here is 3 motors. These are ABS plastic 3D printed. Inside we've got 3-phase brushless motors, which are connected back to a 4-motor speed controller, and then that controller will be connected more professionally than this in the final version to paralleled batteries. These are LiPo batteries. They're 3,000 milliamp a piece, and they discharge between 30 and 60 amps DC. So that'll be plenty of amperage for what we'll be drawing with all the motors. So coming from this ESC controls the actual signal output to all the motors, but the ESC itself is controlled by the Arduino. So this is an Arduino and Raspberry Pi combination in a custom 3D printed sort of holder here. And if you're following the signal is going to come from an external laptop, which is right here. It'll come from a controller, go to the laptop, and then I've got a local area network actually set up right here. So it's broadcasting a Wi-Fi signal. I can connect to that Wi-Fi signal with the laptop. It goes down our tether, which is high flexibility Ethernet cord, really nice stuff. It's going to come down to that, go to the Raspberry Pi. Raspberry Pi parses the signal, sends it to the Arduino, which is on the back side, and then the Arduino then sends that signal to the ESC via pulse width modulation. So that's the basic setup of how the motors work, and then to prove that it actually works, I'm going to do a quick demonstration. And it's as easy as this. I can be connected only over Wi-Fi, so this computer is not connected to anything. All I have to do is run the program, which I'm going to start right now. So yeah, if you want to. So we've got just a really simple Python script right here that we're running based off of Pygame. So we're going to run this, and we're going to connect a battery. And let's see. Of course, it doesn't want to work this time. Let's see. One of the things I also have to do is connect this controller to the laptop over network. So I can just double check. That's often one of the issues that comes up when it doesn't run the first time. So we just run a quick command, and it's waiting for a connection. So, oh, you know what? I think the controller has come slightly unplugged. Not a big deal. So we will. Alright, so the device is connected now. It should work when we run this program. I think when I lifted up the laptop, the controller came unplugged. Anyway, here we go. So that means the motors have initialized, and now you can see they respond to my throttle input here. And it's very smooth throttle response. It's linear. And so these two would be on the sides for forward and reverse and side to side. And then we've got another thruster right here for pitch. And as you can see, it's almost instant response. And one last thing I'd like to point out is you can see the throttle response on here as fast as I can move it. And one thing to remember is that these signals are coming from the controller, they're going into the laptop, they're being sent over Wi-Fi, over a local area network, down the Ethernet cable, which is a 100-foot Ethernet cable, being parsed by the Raspberry Pi, to the Arduino, to the ESC, then to the motor. And it's happening at the blink of an eye, which is really incredible. So that's where we stand right now, and hopefully within the next couple months we'll get the internals waterproofed and inside of the 3D printed housing. We'll get the batteries connected up, and it'll just be a matter of testing at that point. So hope you enjoy.